All right, so here we have 3, 2. And what we're going to do is we're going to be thinking about y equals ab to the x, and we'll just play with this idea here. Now, of course, a is the initial amount. B is your growth factor, growth or decay factor. And these questions ask like, find the constant percentage rate of growth or decay. So when you look at B is one of two things. If growth, B is equal to 1 plus R. If decay, B is equal to 1 minus R. So that'll be more familiar with how we did it in Algebra 2. We focused on little things, not the overall grand scheme of just A times B to the X. And I don't want to do obviously all of these, but like we'll do 2 and maybe 6. Now, first off, we need to know if we're decay or not. If growth, then the absolute value of B is going to be greater than 1. If decay, we talk about B being a number stuck between 0 and 1. It would be a fraction, like a half or 2/3 or something like that, all right? So on number 2, I'm supposed to decide if she's exponential growth or not. She is definitely exponential growth. B is bigger than 1. That's exponential growth. Or B is the guy with the exponent, okay? Since B lines up with 1 plus R, 1.018 must equal 1 plus R. And that means that my rate is 0.018. It's just whatever you are over 1. Now, if you look at number 6, B is going to be this 0.05, which is definitely less than 1. So this is exponential decay. And B is going to line up, since it's decay, we're going to take our 0.05 and think about that lining up with 1 minus R. And you do the math here, you get 0.95. Right? That's the rate of decay. The rate of decay is not 5%. The rate of decay is 95%. Morning, Mr. Adger. All right, in exercises 7 through 18, determine the exponential function that satisfies the given conditions. Let's look at 10. I do feel that with a pre-calc class, I should be able to make a pretty good jump here. But this would just be an initial amount of 5. If I decrease by 59% per week, I only have 41% left. And then we just raise it to the x or the t or whatever variable you like. Let's see here. We have number 12, initial population of 502,000. So 502, 1, 2, 3. We increase at a rate of 1.7% per year, 1.017. Rooftop to the x. Now, if I'm losing you, remember 1.7% is 0.017. And since it's growth, B is 1 plus R. So B is 1 plus 0.017. Let's do one of these. We've got a doubling every 7.5, and you should definitely ask these things if you don't get them. You should. But let's look at one that halves every 6 hours. So if it halves, B is a half. Duh. That's just how it is. All right, so our equation here is y equals the initial amount present, 592, times a half. Now, I don't know if you remember this or not, but we talked about the every situations last year and how it changed. Exponents t over 6, and we spent a lot of time on that. I know we did. I've done it every year. And if there's something you don't know, like make sure you understand 16, 18. Make sure you understand all this stuff. If you don't know it, ask it. All right, in 19 and 20, determine a formula for the exponential function whose values are given in the table. So what we need to do, and I'm just going to do 19, which is about f of x. So this is what I'm interested in, is I need to figure out what r is. That's my big thing. Like, what is r? All right, so if I want r, I just take the second and I divide it by the first, and I check to see if the third over the second is the same. And it should be, because it's supposed to be exponential. It's supposed to be about having a common ratio. So let's pull up my trusty TI-84, and let's see what happens. It looks to me like the f of x is definitely a growth function. G of x looks like a decay function. So let's see here. We take our 1.84. We divide her by 1.472. And I'm sorry, it wasn't R. It was actually B that I'm finding. R would be 1 minus that quantity. And it looks like if I take 1.472 and I multiply it by 1.25, I get 1.84. And I'm going to see if that pattern holds. So if I do this again, I should get 2.3. Let's find out. Winner, winner, chicken freaking dinner. So when I'm talking about 19, my initial amount, by the way, initial amount is when x is 0, is 2.3. And the b term is 1.25. Ta-da! Susan X. Ta-da! All right, moving forward. In 21, 22, determine a formula for an exponential function whose graph is shown in a figure. Easy peasy, BRB. We're just going to use y equals AB 2z x. And by the way, this one is growth. 22 is going to be decay. And let's see here. Y is 4. Sorry. Brain fart here. Looking at this thing, your initial value happens when x equals 0. So A is 4. Okay, so I can write this. I can write y equals 4 times b to the x. And I haven't quite figured out what b is yet. But what I can do is I can plug some crap in. That's what I can do. So I'm looking at the second order pair, and it's 8.05. Y is 8.05 when x is, I believe, 5. Now, what we're going to do is we're going to divide by 4. That's going to give me b to the 5th. Let's see, 8 divided by 4 is 2 point, what? 0125? Yeah, that's right. That equals b to the 5th. I don't know why it says b to the b up there. B to the 5th. Now, the opposite of the 5th power is the 1/5 power. 2.0125 to the 1/5 power is my b value. I don't know what the 5th root of that number is. I feel like I should, though. Like, I feel like it's going to be a nice number. I want to figure it out, but I also don't want to open up that part of my brain right now. 1.501. Ta-da! All right, so full equation here. Y equals 4 times 1.501. All rooftop to the x. Easy peasy, lemon squeezy. 23 and 24 require the logistics function. So I've got that right here. I'm not going to require you to memorize logistics function, but it's not a hard thing to do. We have an initial value of 10, and you can see right here that that kind of gives us A, because that's what A is. We have a limit to growth being 40. That would be C. And we pass through 1, 20. That's to help you figure out what B is. So let's write down what we can write down. Again, I am looking at this formula right here. Limit to growth is C. The initial value is A. That's how it is. All right. And we will have f of x equals 40 over 1 plus 10 e to the negative bx. Now, I know it passes through 120, so this gives me an x and a y, last I checked. I don't know if this is the maximum growth point or not. I have a hunch that it is because it's right through the middle. So I wouldn't be too surprised by that. Anyways, we're going to plug the numbers in. Y is 20 when x is 1. And I really don't have a problem with you guys using a DID4. Your job is just to figure out what x is. That's all it is. So we're going to put 20 into y1. See, math, num, n over d. We got a 40 up top. One plus 10e. E would be second natural log. And that's to the negative x. And we're going to figure out what x is. I don't know what my window is right now from where I used this calculator last, so zoom 6ing. Obviously, I'm going to have to play with the y max a little bit here. And it's going to be super slow. Window, y max, let's do 25. And then I'm going to hit second trace 5 for intersect. And I'm going to press enter 3 times. And there she is. Let's go out 4 decimal places. 2.3026. 2.3026. It is positive. I think I said 2.6. So my actual equation here for number 23 is f of x is 40 over 1 plus 10 times e to the negative 2.3026x. I was actually solving for b there, wasn't I? I don't know why I wrote an x. My bad. Moving forward. So these are basically the same thing. Determine the form of a logistic function, blah, blah, blah. Let's see here. 29, not doing. All right, the population of Smallville in the year 1890 was 6,250. That's not so small. Assume the population increased at a rate of 2.75% per year. So if we're increasing at 2.75% per year, that would make B be 1.0275, because I need to multiply by 1 and then the 2.75% as well, put it all together. My equation here would be y equals the initial amount present, 6,250, times 1.025 to the, does it every year, per year, so to some t or x. Now, estimate the population 1915 and 1940. 1915 is going to be what, 25 years after the initial amount? So the time is 25. So y would be 6,250 times 1.025 times raised to the 25th power. And 1940 was 50 years. So this would be y of what? 25. Y of 50 would be 6,250 times 1.025 to the 50th power. And then you push the buttons. If I can push buttons. 6250 1.025 rooftops to the 25th power. So there's the first one, 11,588. These are people. We don't round people down. You don't round people down. You round people up. There's no such thing as 3/5 of a person. We know these things. And then the other one's going to be 21,482. All right, part B, predict when the population reached 50,000. Of course, your setup is quite obvious, at least it is to me. You're going to say 50,000 equals 6,250 times 1.025 to the t. And I don't know why, but I feel like doing logarithms. So we're going to divide both sides by 6,250. Let's see what that left-hand side reduces down to. I was just looking at the dual enrollment grades on their logarithm test. That's what they were. That'll give us 8 equals 1.025 to the t. And what we're going to do is we're going to ln both sides. We're going to have t natural logs of 1.025 on the right-hand side because exponents go to the front. And then we're just going to simply divide out by the natural log of 1.025. And then we're going to call it a good day because we're just going to push some buttons and be done with this thing. The natural log of 8 sitting pretty over the natural log of 1.025 is roughly 84. So it's a little over 84 years. So you do 1890 plus 84, and I believe you get 1974. Let's see here. I know there's 2 radioactive decay problems. I'll do this one. The half-life of a certain radioactive substance is 65 days. There are 3.5 grams present initially. Express the amount of substance remaining as a function of time. So if it's half-life, like legit, B is a half. Right? Legit, B is a half. So your half-life formula is y equals a times a half here to the t. And there are 3.5 grams present initially, so y is 3.5 times a half. And it's 65 days, so I actually have to say t over 65. Ta-da! All right, that's part A. Express the amount of the substance. Oh, and I do want the amount of the substance, so I should use better notation. I should call this amount as a function of time is B. When will there be less than 1 gram remaining? So the goal is to get to 1 and to be less than that. Do you want to do logarithms? Do you? Probably not. Worth a shot. So I went to y equals. I'm pushing buttons. I'm going to do a zoom 6. Probably going to have to look pretty far to the right because it takes 65 days just to cut it in half. And you're going to have cut 3.5 once. You're going to get 1.75. You're going to do it again, and you're going to get something less than 1. So it's going to take almost 100 days likely. Probably a little more, maybe a little less. I don't know. But here you can see the half-life going down. So let's look out. 2 half-lives would be 130 days. Because 65 times 2 is 130, kids. And I should see a crossing happen. And what I want to do is I want to find that crossing, and I want to think about everything to the right of that. When does this thing happen? Well, it looks like it did cross. So second trace 5, enter 3 times. Bam. So 117.4781 days. So for the time is bigger than 1 point, sorry, I forgot my number there. 117.4781. Bam. All right, I'm almost done here. Got a bacterial growth, radiocarbon dating, spread of the flu, population of deer. Let's do spread of the flu. Number of students infected with flu at Springfield High School after T days is modeled by the function P as a function of time. So population as a function of time is 800, which would be the carrying capacity, which is the maximum number of kids that can be infected by the flu. So what was the initial amount? Right there. Well, let's check that. It's C over 1 plus A. So A is 49. But the initial amount is equal to C over 1 plus A. All right, so C is 800. 1 plus A would be 1 plus 49. This is 800 over 50. And you just do the math, right? It looks like 16 kids. Now, you also could have gotten that just by, being extremely lazy and going to y equals and typing in the frickin' equation. Yeah, it's worth doing just to check. We got a 49, we got an E, negative 0.2 T. Clear. I'll play with my window. I'm going to look up 900 units since I know the carrying capacity is 900. And that is not what I meant to put there. I'm just going to leave that as 10 for now. I'm going to look up 900 units. So y max to be 900. And I'm going to hit the graph button. And let's see if my initial amount was 16. Second trace value when x is 0, when time is 0, is winner, winner, chicken dinner, 16. When will the number of infected students be 200? So part B here, we're just going to set 200 equal to this equation. And I guarantee the author of your text intends on you to do this graphically. So it's not a hard problem to do. Let's throw a 200 in y2 and use the intersect feature. I'm going to go ahead and look into the future. I'm going to change my x max to be 60 days, 2 months, whatever. Second trace 5 for intersect. And of course, part C is what day do we close the school, which is the one everybody cares about. Nobody cares that people are sick. I'm right there with you, to be quite honest with you. If it doesn't affect me, what's the big deal? So 13.9661 days, which would be the 14th day. So 14 days on B. And then on C, we're going to just change that from 200 to a 300. And we're going to see when they actually close the school down. When COVID was going around, we used to talk about this, like, hey, are they going to close this down? We got so many kids out, and none of us were really sick. We just didn't want to be here. That's the reality of it. We're all not good people. We didn't care if people were getting sick. We just didn't want to be at work. All right, so I drafted, enter, enter, enter. And there you go. So around 17 days, 16.904. 17th day, there won't be school. Because sometime during the 16th day, the 300th kid got sick. And I think that's all I feel like doing. Yeah, that's it. Later.